Okay, 6.3 we're going to do inverse functions of exponential and logarithmic functions. We introduced inverse functions in chapter 5, so now we're just doing it, finding the inverse for these particular types of functions. So for A, it says find the inverse algebraically, f of x equals log base 4 of x. Okay, sometimes it's easier to rewrite this in terms of y instead of the function notation. So I'm going to rewrite it as y equals log base 4 of x. To find the inverse, the x and y interchange, so the y becomes an x, and the x becomes a y. Okay, now normally we solve for y after this. We don't really know how to solve for y, but we do know how to rewrite this in exponential form, so we're going to do that. If we do exponential form, the base is this little number. So 4 to the exponent is whatever the logarithm is equal to, and then it equals to the argument. Okay, now we normally solve for y. This is y equals. So I'm just going to rename this as f inverse of x equals 4 to the x. And I found the inverse. Okay, at b, same idea, g of x equals ln of x. If it's helpful, you can change it to y equals ln x. If you're okay interchanging the variables immediately, you can do that. This is the most important step when we change the y to an x and the x to a y, because we're changing the input and output. Okay, now on this example, we rewrote it in exponential form. I want to do the same thing here to solve for y. What's the base for ln? Natural log, the base is e, so the base is e. The exponent is whatever the equation equals to. And e to the x equals the argument, which is y. Since I'm solving for g inverse of x is e to the x. Okay, let's try some. They're a little bit trickier. Okay, but I'm going to start it the same way. I write it as y equals, and again, if you're comfortable skipping that, you're okay with that. I'm going to keep it so I remember that I'm interchanging my x and y because my input and output are changing. X equals the log of y plus 3. Can I cancel the plus 3? No, it's in parentheses. It's part of the argument of the log. So I'm going to rewrite this in exponential form. The base is what? 10, because this is a common log. So 10 to the x equals y plus 3. I want to solve for y, but I still have this extra plus 3 over here. So we're going to go ahead and minus the 3 to the other side. Okay, and then I'm going to relabel this because this is the inverse of h. So this is h inverse of x equals 10 to the x minus 3. Let's look at D. Okay, I'm going to rewrite it with the y, which again, you don't have to. Okay, now I'm going to interchange the variables, which is the most important step to finding the inverse. Okay, now I want to solve for y. Can I cancel the negative 13? I can't because it's not in parentheses, it's just there. So I'm going to add the 13 to the other side. Okay, now that the log is by itself, let's rewrite it in exponential form. The base is 2. The exponent is x plus 13, so make sure the whole thing is in the exponent spot, equals y. Okay, and then the only thing I'm going to do is relabel this because this was the inverse of j. So j inverse of x is 2 to the x plus 13. Okay, let's look at these. Oh, these are exponential functions, but I'm going to start it the same way. Interchange my x and y. Okay, now how do I solve for y? I'm not sure, but I'm going to rewrite it in exponential form because I do know how to rewrite it like that. Okay, exponential form, log. What's the base? The base is 3. Argument is x, and then it equals to the exponent. So by rewriting in exponential form, I actually solve for y. So let me just recall this f inverse of x equals log base 3 of x. Which is nice, which makes sense because the inverse of a log function was exponential, and the inverse of the exponential ends up being a logarithmic function. Okay, f is very similar, so go ahead and feel free to work ahead. Exponential form, log, the base is 8, the argument is x, and it always equals the exponent if it's a log. So this is called g inverse of x is the log base 8 of x. Okay, a couple more and then we'll graph. Okay, same. Y equals 5 to the x minus 4. Change it. Okay, this one, it does look a little different. Can I add the 4? No, it's in the exponent spot. I can't add the 4. So I'm going to have to rewrite this exponentially. Log base 5 of x equals the exponent. So I have y minus 4, so I do need to move the 4 over. And then I'm just going to relabel this as H inverse. Okay, one more solve. Okay, y equals e to the x plus 12. Most important step, change the y to an x, the x to a y. Okay, can I minus the 12? I can minus the 12. It's just sitting there. Okay, so I get x minus 12 equals e to the y. Are we ready for logarithmic form? Yes. Okay, so log base e, instead of writing log base e, I'm going to say ln of x minus 12. I'm going to put the x minus 12 in parentheses because I'm logging the whole argument, and that equals to the y. Then we'll rewrite this as j inverse of x equals the ln of x minus 12. Okay, if you wrote your answer like this, it's technically also correct. We just never write log base e. We always change it to natural log because we know that that automatically is log base e. Okay, now let's actually find the logs, graph them, and then look at them to make sure they look like they are in fact inverses of each other. Okay, so f of x is log base 5 of x. Actually, I think I'm going to graph this first. How should I graph log? The log base 5 is 1. 1, 2, 3, 4, 5, 1. The x-intercept, log base 5 of 1 is 0. And the log base 5 of 1/5 is -1. The asymptote is the y-axis. So don't cross your y-axis. Okay, and I'm going to label that as f before I forget. Okay, now I'm going to go ahead and find the inverse. Change the y to an x, the x to a y. Okay, I'm going to rewrite it in exponential form. 5 to the x equals y. So f inverse of x is 5 to the x. Okay, I'm going to go ahead and graph this now, and then I'll stare at the asymptotes. Okay, so 5 to the 0 is 1. 5 to the 1 is 5. 1, 2, 3, 4, 5. 5 to the -1 is 1/5. Don't cross your x-axis because that's your asymptote. F inverse. Okay, now f of x was my blue function. The asymptote of my blue function was we didn't cross the y-axis. Since the y-axis is a vertical line, the asymptote is at x equals 0. The asymptote of f inverse is the x-axis. That's a horizontal line, so the equation is y equals, and it's passing through the origin, so it's y equals 0. Now let's look at this to make sure it makes sense. Okay, if the asymptote of the function is x equals 0, the asymptote of the inverse should be y equals 0 because the x and y interchange. Okay, if we want to verify this visually, we graph this line of symmetry, which is y equals x. Y-intercept is 0, slope is 1. Right through the corners. If you look across that line, f and f inverse do look like they're symmetric across this line. So they look like inverses as well. Okay, let's try one more. Okay, I'll graph it first. Okay, so normally exponential, the asymptote's at y equals 0, but this one's going to go up 2. So let's go ahead and move it up 2 because it's going to help my graph. So y equals 2. Okay, normally I'm at 0, 1, but I'm moving up 2. I'm normally at 1, 3, up 2, 1/3, up 2. Okay, now let me find my inverse and then we'll compare. Can I minus the 2? Yes, because it's just a normal minus 2. Okay, if I rewrite it in logarithmic form, it's log base, the base is 3, the argument is x minus 2, and the exponent's y. So this is f inverse of x is log base 3 of x minus 2. Okay, now let's compare the graphs. Okay, normally the asymptote for a log function is the y-axis, but this one is moving to the right 2. So let's move it to the right 2. Which means it's at x equals 2, which makes sense because the asymptote for the function was y equals 2. Okay, now where do we normally graph? We normally graph the x-intercept is 1, 0. Let's put it on the line. And then we normally go 3, 1. I'm going to start from the asymptote 1, 2, 3, 1. And then we normally do 1/3 negative 1, which is down here. Okay, let me sketch it in, respecting only my green asymptote, because that blue asymptote does not belong to this function. Okay, it does not ask for the axis of symmetry, but let's look at it to make sure it looks correct. Okay, yes, this does look like it's reflecting over to this. The asymptotes look like they are the asymptotes of inverses, so f and f inverse look like inverse functions.